Glucose is found to contain 40% carbon, 6,72% hydrogen, and 53,3% oxygen by mass. Its molecular weight is 180. You have to determine the simplest, also called empirical, and the molecular, also called true, formulae of glucose. We have been given the mass ratio of carbon to hydrogen to oxygen within a glucose molecule in a percentage form. If we were to have 100 grams of glucose, this would mean that we would have 40 grams of carbon within that, 6,72 grams of hydrogen within the 100 grams of glucose, and the remainder, 53,3 grams, would be oxygen. This is a mass ratio, but if we want to give a formula, we need to find the particle ratio. We need to convert this mass ratio into a particle ratio. We need to know how many moles of carbon make up 40 grams of carbon, how many moles of hydrogen have a mass of 6,72 grams of hydrogen, and how many moles of oxygen atoms have a mass of 53,3 grams. And this is something you should easily be able to find using the molar mass information on the periodic table shown here. Pause this video until you have found the answers to the questions of what the particle ratio is from this mass ratio. These are the answers you should have found. 40 grams of carbon is 3,33 moles of carbon. 6,72 moles of hydrogen has a mass of 6,72 grams, and 3,33 moles of oxygen has a mass of 53,3 grams. Now we should write this ratio in its simplest form. We do this by dividing through by the smallest number present, 3,33. That gives us the ratio 1:2:1. We write this in the formula, the simplest formula, 1:2:1, C1, H2O1. When we write the formula though, we leave out the ones and just write CH2O. But what you need to appreciate is that although this is the ratio, 1:2:1, of carbon to hydrogen to oxygen particles within a molecule of glucose, it doesn't necessarily mean that there really is only one carbon atom and two hydrogen atoms and one oxygen atom in a glucose molecule. Because you see, the ratio 1 carbon is to 2 hydrogen is to 1 oxygen can be written in infinite forms. This is exactly the same ratio as 2 is to 4 is to 2. So if there really were 2 carbon atoms in there, and 4 hydrogen atoms in there, and 2 oxygen atoms in there, that would still have a ratio of 1:2:1. And so would a ratio of 3:6:3, or a ratio of 10:20:10, or 100:200:100, and there are infinite other possibilities which all also have the ratio 1:2:1. So the question is, yes, we know that the ratio of carbon to hydrogen to oxygen in glucose is 1:2:1, but what is the actual number of carbon atoms in a glucose molecule? And what is the actual number of oxygen and hydrogen atoms in that glucose molecule? How can we know? In other words, how can we know what the molecular or the true formula of glucose really is? The clue is using the molecular weight, which is 180. What does this mean? Well, let's for argument's sake take it as if a molecule of glucose really did consist of 1 carbon atom, 2 hydrogen atoms and 1 oxygen atom. What then would the mass of that whole molecule be in AMU per molecule? How do we find this out? Well, let's look at the periodic table. Remember that this number at the bottom of each element, we have always been using it as the molar mass, which means that 1 mole of carbon has a mass of 12 grams. And that is true. But it has another meaning as well, which is atomic mass. And that means that 12 AMU is the mass of 1 atom of carbon. 1 AMU is the mass of 1 atom of hydrogen. 16 AMU is the mass of 1 atom of oxygen. AMU stands for atomic mass units. Now, don't fall into the trap of thinking that 12 AMU and 12 grams are the same thing. 12 AMU is not 12 grams. 12 AMU is the mass of 1 carbon atom. 1 carbon atom is so minute that you wouldn't even be able to see it with your eye under a microscope, under the strongest microscope possible. 12 AMU is a very, very, very light measurement of mass. 12 grams, on the other hand, is relatively much. It's quite heavy. I mean, it's not very heavy. Maybe it's 2 or 3 pencils. But still, it's something that you can feel. It's a kind of mass that you can feel, whereas 12 AMU is so, so small, you can't feel it. So don't think that I'm saying that atomic mass and molar mass are the same thing. They are not the same thing as one another, but it just so happens that the number given on the periodic table, 12 for carbon, it has 2 meanings. It has a meaning of molar mass for carbon, and it has a meaning of atomic mass for carbon, even though those 2 things don't mean the same thing. And the reason why they don't mean the same thing, even though they have the same number 12 for them, is because their units aren't the same. Molar mass's unit is grams per mole. Atomic mass's unit is AMU per atom. Now, actually, we could use either of these, molar mass or atomic mass, to help us to convert the simplest formula into a true formula. But let's choose one of them, and the one we choose is atomic mass. So we're going to find, obviously, it's not speaking about an atom, but a group of atoms, therefore a molecule, we'll speak about molecular mass, which we find from adding the atomic masses of the component atoms. And so what would the molecular mass of CH2O be? It would be 30 AMU per molecule. So 1 molecule of glucose, if this were the real formula of glucose, would be 30 AMU. That would be the mass of 1 molecule of glucose. If we'd instead found the mass in grams of a whole mole, well, we would have found it to be 30 grams per mole, and that would be another way to solve this problem. But we have chosen to work with the mass in AMU per molecule. So let's stick with that. Now, we've seen that the molecular weight is 180. However, we found using this formula that the molecular mass would be 30 AMU per molecule, even though we've just been told in the question that actually it's 180 AMU per molecule. These 2 values are not equal. What does that tell you? It tells you that this formula is not the truth. Although the ratio is right, 1:2:1, the actual numbers 1, 2, and 1 are not right. If they were, then they would give the right mass for a whole molecule, but they don't. The right mass for a whole molecule is 180 amu, but we found that this would only have a mass of 30 amu for a whole molecule. So by what factor do we need to increase our number of atoms within a molecule to get this right? Well, 180 divided by 30 gives us 6, telling us that 180 is 6 times bigger than 30. And so we need to increase everything by 6 times. In other words, the formula should not be CH2O, but rather C6H12O6. And if we had a molecule of this formula, it would indeed have a molecular mass of 180 amu per molecule, and it would also have a molar mass of 180 grams per mole. You can go check it out. And so this is the real formula of glucose.